Welcome to the Hodja on Everything, the Space. Chapter 5, The Great Planet Lottery. In the previous episode, we discovered that stars are not eternal lights decorating the night sky. They are born, they live, they manufacture the elements that make planets and people, and eventually they die. Some end their lives quietly. Others explode as supernovae, scattering the raw materials for future worlds across the galaxy. In a very real sense, every planet begins as recycled stardust. Today, we follow that dust as it assembles itself into something even more familiar: worlds. Some become scorching balls of rock. Others grow into enormous gas giants. A fortunate few become surprisingly hospitable. Welcome to what might be the greatest game ever held, the planetary lottery. Imagine a young star surrounded by an enormous spinning disk of gas, dust, and tiny fragments of rock. That is how almost every planetary system begins. Gravity pulls particles together. Pebbles become boulders. Boulders become mountain-sized objects. Mountains collide until entire planets emerge. The universe, it seems, does not operate a planet factory. It simply starts countless traffic accidents and patiently waits a few million years to see what survives. What makes this remarkable is that every planet begins with roughly the same ingredients, yet the finished products look astonishingly different. One planet ends up covered in oceans, another develops poisonous clouds, one acquires magnificent rings, another grows storms larger than entire planets. Give the universe one recipe and enough time, and apparently it refuses to cook the same meal twice. Our own solar system illustrates this beautifully. Close to the Sun, we find the rocky planets: Mercury, Venus, Earth, and Mars. Small, dense worlds built mostly from rock and metal. Beyond them lie the gas and ice giants: Jupiter, Saturn, Uranus, and Neptune. The first two are dominated by hydrogen and helium, while Uranus and Neptune contain much larger amounts of water, ammonia, and methane beneath their thick atmospheres. It is rather like a family photograph. Four sensible rocky children standing neatly at the front, followed by four enormous relatives who appear to have eaten the furniture before posing for the picture. Why the difference? Heat. Close to the young sun, temperatures were so high that only heavy materials such as rock and metal could remain solid. Lighter gases were blown away. Farther out, where conditions were much colder, those gases could remain, allowing giant planets to grow into truly enormous worlds. Distance, it turns out, is one of the first lottery numbers every planet receives. And that is perhaps the most important idea of today's episode. A planet's story is written long before anyone could ever stand upon it. Its size, composition, atmosphere, orbit, and even its future are influenced by where it formed. We often imagine planets choosing their destinies. In reality, they receive a very unusual set of opening conditions and spend billions of years dealing with the consequences. Our planetary neighbors could hardly be more different. Mercury races around the Sun in just 88 Earth days, making it the shortest year in the solar system. If you lived there, birthdays would become so frequent that eventually you might stop celebrating them altogether. Venus, meanwhile, seems to have misunderstood the instruction manual. It rotates backwards compared with almost every other planet, meaning that on Venus the Sun appears to rise in the west and set in the east. It is also the hottest planet in the solar system. Being closest to the Sun, it turns out, is not the only way to become unbearably warm. A runaway greenhouse effect can be remarkably persuasive. Earth, by comparison, appears almost suspiciously ordinary. We often overlook just how unusual ordinary really is. Mars, on the other hand, looks like it once had ambitious plans before something went rather wrong. It is home to Olympus Mons, the largest volcano known in the solar system. Mount Everest rises almost 9 kilometers above sea level. Olympus Mons stands roughly 22 kilometers high. If mountains could exchange polite conversation, Olympus Mons would probably look at Everest and say, "That's adorable." It is so large that standing on its summit, you would not even be able to see the whole mountain because Mars curves away beneath your feet. Then we arrive at the giants. Jupiter is so enormous that more than 1,000 Earths could fit inside it. Calling Jupiter merely a planet almost feels unfair. It is more like a failed star with extraordinary self-confidence. It has also spent billions of years acting as the solar system's unpaid security guard, its immense gravity capturing or deflecting countless asteroids that might otherwise have wandered toward the inner planets. Quite a few asteroids heading inward have met Jupiter first and quietly reconsidered their travel plans. Saturn, meanwhile, has become the family's celebrity thanks to its magnificent rings. Earth invented jewelry. Saturn decided to wear it. Uranus deserves special recognition for refusing to behave like everyone else. Most planets rotate with only modest tilts. Uranus rotates while lying almost on its side, tilted by about 98 degrees. It is less a spinning planet than a rolling one. Every other planet leaned a little. Uranus committed fully to the horizontal lifestyle. Neptune, the outermost giant, completes one orbit in about 165 Earth years. On Neptune, hardly anyone would ever celebrate a second birthday. Perspective, once again, solves many problems. Some of you may also be wondering about Pluto. Yes, it was officially considered the ninth planet until 2006, when astronomers rather awkwardly changed the definition of what counted as a planet. Nothing actually happened to Pluto. It did not shrink, explode, or wander off. The rules changed. Unfortunately for Pluto, the solar system's planning department turned out to be every bit as unforgiving as the real one. Even the planets' names tell a story. Nearly every planet in our solar system is named after an ancient Roman god. Mercury, the messenger; Venus, the goddess of love; Mars, the god of war; Jupiter, the king of the gods; Saturn, the god of agriculture; Neptune, the ruler of the seas; and then there is Earth. After naming the others after powerful deities, humanity apparently looked down at the ground beneath its feet and called this one Earth. Sometimes mythology is wonderfully grand. Sometimes it is surprisingly practical. Not every lottery ticket wins, and the same is true of planets. One of the most important numbers in the planetary lottery is distance from the parent star. Too close, and water cannot remain liquid. Too far away, and it freezes solid. Between those extremes lies what astronomers call the habitable zone, more affectionately known as the Goldilocks zone. Not too hot, not too cold, just right. Apparently, Goldilocks has been quietly working for astrophysics all along. Officially, it is the region where liquid water could exist on a planet's surface. Unofficially, it is the part of the solar system that is not immediately on fire. Of course, being in the habitable zone does not guarantee life. It merely means the property is worth viewing. Distance also determines something else we experience every day without much thought: the length of a year. The closer a planet is to its star, the faster gravity pulls it along its orbit. Mercury races around the Sun in just 88 days. Neptune takes 165 Earth years. The solar system, it seems, cannot even agree on what counts as a birthday. Planetary tilt matters just as much. Earth happens to lean by about 23.5 degrees, giving us familiar seasons. Remove that tilt and much of our seasonal variation disappears. Increase it dramatically, and climates become far more extreme. Every planet receives a different spin of the cosmic roulette wheel. For centuries, we assumed our solar system might be unique simply because it was the only one we knew. Today, we know better. Astronomers have discovered thousands of exoplanets orbiting distant stars, with thousands more awaiting confirmation. Some are larger than Jupiter, yet orbit closer to their stars than Mercury does to the Sun. Others are rocky worlds only slightly larger than Earth. Every discovery reminds us that nature possesses far more imagination than we do. If our solar system is one neighborhood, the galaxy contains billions more, each with its own architecture, its own history, and its own lottery results. Perhaps that is the most humbling lesson of today's journey. Earth is not the center of the solar system, the galaxy, or the universe. It is simply one remarkably fortunate world that happened to receive an extraordinary combination of numbers: the right size, the right chemistry, the right distance, the right atmosphere, and the right history. Winning the planetary lottery did not guarantee life, but it certainly gave life an opportunity. As it turns out, buying the house was only the beginning. In the next episode, we will ask what may be the oldest question humanity has ever asked beneath the stars. If planets like ours exist throughout the galaxy, are we alone? We will explore habitable worlds, the search for extraterrestrial life, the latest discoveries from distant atmospheres, and one mystery that has puzzled scientists for generations. If the universe has printed so many lottery tickets, why has only one of them written back? This concludes Chapter 5 of The Space, the Great Planet Lottery. Thanks for listening. See you in the next episode.